So let's look at a quadratic trinomial. Quadratic because the largest degree is 2, it's an x squared, and trinomial because I have 3 terms, a 9x squared, a 30x, and a 21. And these are probably the most common factoring that we'll be doing throughout the rest of the year. First thing that I always look for is a greatest common factor, which I do have here, happens to be 3. When I factor out that 3, I'm left with 3x squared plus 10x plus 7. Now, in order to factor this, I'm actually going to look at the coefficient of the x squared and of the constant term there. I'm going to multiply those two values together. 3 times 7 gives me a positive 21. I'm emphasizing the positive because I'm now going to look at the factor pairs of 21, which are 1 and 21, or 3 and 7, and figure out which of those factor pairs will add up to my middle coefficient of 10. Of course, that's going to be just the one option of 3 and 7. So what I'm going to do is I'm going to rewrite 10x using the 3 and the 7 instead. This will create a grouping problem that'll be a lot easier to actually work with. Now, the order that we choose here doesn't make too much of a difference. Work will look a little bit different if you change it to be 7x plus 3x, but it will work out exactly the same in the end. Now that I have this set up like this with 4 terms, I'm going to try grouping. You group the first 2 and the last 2 and see if I can end up with the same term. The 3x squared and 3x share, well, a 3x, leaving behind one of those x's and just a 1. The second set of terms there, the 7x plus 7, share a positive 7, leaving behind a, oh, what do you know, x plus 1. Because these two are the same, I'm just going to have to pull that out in front, although still inside the parentheses with the 3 out in front, and then combine the terms that were left over, the 3x and the plus 7, to make 3x plus 7. And nothing further that I can do there. That's how you factor a quadratic trinomial.
For this one, we had 6b, nope, that's not a 6, that's a b, sorry about that, squared, plus 16b, plus sticky floor, because 8 times 8 is 64, and 8 plus 8 is 16, b plus 8 squared was derived.
So, a little bit of magic, or so it appears here. This is actually one of our special products, our perfect square trinomial. It comes from the equation that a squared plus 2ab plus b squared can be written as a plus b squared, and that's always going to be true. Now, the key was that our first term was a perfect square, our last term was a perfect square, and if I took the square roots of those, being 8 and b, multiplied those together, and also multiplied by 2, I ended up with my middle term there of 16b. And so that's why we can jump right from this down to here. The b plus the 8 being equivalent to, in this case, a plus b, where that's the square root of the first term and the last term. So, nice job, guys.
Oh. So, for this one, we started out with 9k squared
Plus 6,
6k,
66k,
oops, 66k, plus 21.
then it was grouped
Do your voice for your first one.
to 9k squared, minus, nope, that's a plus, sorry about that,
Plus
63k, plus 3k, plus
2K.
21.
because 63 plus 3 equals 66,
And 63 times 3 equals 189,
which is
9 times 21.
What? You take that from Mike, isn't it?
Then we pulled the 9k from the first group, yielding k plus twazawad, and a 3 from the second group, yielding k plus 7, which gave us the final Oh. Oh. Join the Maze Window side. John, over and out.
What about the old audio?
Alright, so
You got k squared minus 13k plus 40. Want to multiply the 1 by the 40. Write out the factors of 40. You got 140, 220, 4 and 10, and 5 and 8. So 5 and 8, that's gonna subtract those bad boys, get to negative 13. Alright, k squared minus 5k minus 8k plus 40.
Yes.
And then just group those.
Yes, you can do it with grouping. You can do it with grouping.
Greatest common factor of k squared minus 5k is k.
The perfect square trinomial.
Greatest common factor of negative 8k plus
The way
40
that you
is
multiply the first number and the
negative
last
8.
number, right? It creates a perfect square. And then whatever, in those special cases, whatever the square root of that number is half of what the number is in the middle.
Factor that out.
If you multiply and you get 100, the number in the middle is going to be 20, because the square root of 100 is 10.
Final answer comes
So
to
that,
k
you're just gonna say,
minus
oh, well,
5
10 and 10 add up to 20
and k
multiply
minus
by 100.
8.
It's gonna happen.
See if it worked. Alright, so, oh jeez.
For this trinomial, first you have to multiply the outside, both outsides, to get what you need to multiply to. 3 times 4 equals 12, so you must find what multiplies to 12 and adds to negative 8. Negative 6 and negative 2 are those numbers. Then you group you rewrite the equation as 3n squared minus 6n minus 2n plus 4. Then you group. After you group 3n squared minus 6n and negative 2n plus 4, you find the GCF of both groupings. You get 3n parenthesis n minus 2 and negative 2 parenthesis n minus 2. Because they are the same, you can move on. Then your final group is 3n minus 2, which is the GCF of both problems, and n minus 2, which is the original answer you have. Then you FOIL and come up, and if you have the same answer as the original problem, you are correct.
Alright, just a quick comment here. It's just really a little technical thing. In these two terms, you've rewritten the negative 8n correctly, but you've used a lowercase n. It's a technical thing, but you should maintain the same type of variable throughout the entire thing. I agree with your final answer here being 3n minus 2 times n minus 2. Just be careful about the variables. Nice job.
Okay, so you're going to start with the problem, n squared minus 11n plus 10. So then you're going to multiply 1 times 10. You multiply the 2 outside, and that's going to give you 10. And you're going to try and get two factors of 10 that equal negative 11. And so 10 and 1 are the 2 factors of 10. And you make those negatives so they equal negative 11. So that works. And then you're going to continue by putting negative 10 and negative... by putting negative... Alright, so you're going to start with the problem, n squared minus 11n plus 10. And then you're going to multiply the 2 outside numbers, so 1 and 10. and you're going to get 10. And then you're going to find the factors of those that you can add up to equal negative 11. So the factors of 10 would be 10 and 1, and you're going to make those both negative, so they add up to negative 11. And then, moving on, you are going to put the negative 10 and negative 1 into the equation. So keep the n squared and then add in negative 10n minus 1n plus 10. So you're going to make it a 4-digit equation. So then you're going to group those together. You're going to group the n squared and the negative 10n together. So then you get 1n, n minus 10. And then you're going to group the next two, negative 1n and 10. So all together you're going to get 1n, n minus 10, minus 1, n minus 10. And then you get your answer, which is n minus 10, n minus 1 within parentheses. So thank you and have a nice day.
Alright guys, so no explanation was provided for this one, but the work is correct. It is very well done, so nice job on that. This is one of those special cases. You know, it's a perfect square trinomial. My first term is a perfect square, that would be 7n squared. My last term is a perfect square, that would be 4 squared. And the middle term, negative 56n, comes from taking these two numbers, these two terms, multiplying them, which would be negative 28n, and then doubling it. And that's how you could actually jump right from here to here to get the special product, but otherwise the way that this was done was just fine. Nice job.
Okay, so first we multiply this time the first, yeah, because there's the negative 1 right there. So, oh, we did this on the board. So then it's plus, or it's a positive 8, so it has to add up to negative 6. So that could be, that would be like negative 4 plus negative 2.
Yeah.
Cool. So then you do
Is it? Oh shoot! I forgot.
b. You would do b minus 4 b minus 2b plus 8. And then you group them, and you can take out a b from the from the
First.
So it would be b times negative 4. And then you can take out
Negative 2.
negative 2.
Wait.
Right, okay. 2b plus 4.
That'll be minus 4.
Minus 4.
Write it down here, so then you can refer to it back as you go through. You can practice. I mean, you can also just go right forward and see what it is.
Oh, because it's b squared. Okay, right. Okay, later. No, we understand. Okay, so this is a b squared. We'll take out this step for now.
Should we like redo our recording?
No, it's fine.
Okay.
Squared. Okay, that's better. So you can take out b, and then it's
Okay.
b minus 4. Then you can take out
Wait, why'd you put the parentheses?
right, okay. Can you just no?
Yep.
Okay. And then we take out negative 2.
Like that.
and get b minus 4. How
Oh, there we
convenient.
go. Okay.
So then
Only took a
b
couple tries.
minus 4
And
times
b minus
b
2.
minus 2.
Oh, we did it. We're okay.
Wow.
You're using the chalkboard.
Yeah. Such talent.
It can work, but that's a tricky one to factor.
Okay.
So what do you
Thanks.
I give anyone who is willing to go back and fix the mistake there a lot of credit for sticking with this problem. And I kind of admire the fact that you didn't re-record. So, nice job, ladies.
Hello again. So first, we're going to multiply these
4
two
and 4
things. So
to
that's
get
16, and it's a positive, so we have to add two things. And we can add 16, negative 16, and negative. And then, so that's what we're going to use for that.
To get the negative 17.
Yeah.
So we're
So
gonna get
first we do 4n squared minus 16n minus 1n plus 4. Then we do the grouping method, and you can take out 4n from the first term to equal 4n times n minus 4. Okay. And then on the second term, you can take out a negative 1. So negative 1 times n minus 4. Wow, two same terms.
So that could be written as n minus 4 squared, or n minus 4, right?
No, 4n minus 1.
Oh, never mind. That's wrong. I'm wrong. Don't listen to me.
Wow, we did it again, folks.
Because of these two things.
In the step above, not this step.
Plus 9.
Because if you do this,
We find on
then that would be a negative 10.
Thank you.
Cool.
You take out
Peace.
that negative from here,
Allie, your goodbye.
Oh, thanks for watching.
do that. So you, in the front,
All right.
Okay, bye.
So the original problem for this one was x squared minus 5x plus 6. And so the way we learned how to do this was put a coefficient of 1 there. And what numbers multiply to 6, but add to 5. And so it was 3 and 2. And so the way we set it up was x squared minus 3x minus 2x plus 6. And then we went ahead and grouped them. And we pulled out an x from this original, and we were left with x minus 3. And then we pulled out a negative 2 from this original, and we were left with an x minus 3 as well. And then we grouped the x and the negative 2 to get x minus 2, and then the x minus 3. So the original problem for this one was 2v squared plus 11 plus 5. And so 2 times 5 equals 10, and two numbers that multiply to 10 but add to 11 are 10 and 1. And so what we did was we wrote it out fully before we drew the parentheses. So it was 2v squared plus 10v plus 1v plus 5.
And then from this original, we pulled out a 2v, and that was left with v plus 5. And then from this original, we pulled out a 1, which also left us with v plus 5. And then we grouped these two terms, and it was 2v plus 1, and then the v plus 5.
This problem is n squared minus n minus 56. So first, you are going to multiply 1 times 56, negative 56, and it will get you negative 56. So you want to find factors that will subtract to get negative 56, and that is 7 and 8, and it will be a negative 8. So then you can put those into your new equation. So it will be n squared plus 7n minus 8n minus 56. Now I can group by taking my first part of the equation and the second part. So it will be, I can take a common factor of n first, and then it will have to be n plus 7 for the first part. In the second part, it will be minus 8 to get n plus 7 in the parentheses. Then, to get my final answer, these in the parentheses, they are the same, so I will be able to do n plus 7 and n minus 8. And that is your final answer.
Okay, so this is my problem. And I'm starting off at I multiply this number and this number, and it will help me to group it. So it's 189, and then I'm trying to find two numbers that if I multiply them, it would give me 189, and it will, if I add them up, it will give me 66. So these two numbers, 63 and 3. So what I'm doing right now is I substitute these numbers. So it's like okay. So now I'm grouping. So it's gonna be 3k parentheses 3k plus 1, because if I multiply the 3k by 3k, it will give me 9k. And if I multiply the 3k by 1, it will give me the 3k. And then I'm using the common factor, that is 21, and it will give me 3k plus 1, because if I multiply 21 by 3k, it will give me 63, and if I multiply the 21 by 1, it will give me 21. And because these are the same, I can just write my final answer like that. And that is my final answer.
Very nice work on this problem. Just one thing I think I mentioned on a couple of other ones. 3k plus 21 actually has a common factor of 3. So I'm actually going to take out a 3, leave behind a k plus 7, and then leave behind 3k plus 1. And that's actually going to be my totally simplified and factored final answer. Really nice work in this problem.